Alright, let's look at the homework 15.4, problem number 8. Right, so we want to find the volume of the solid, which is inside the cylinder, x squared plus y squared equals 9, and also inside the ellipsoid given here. Alright, so let's do that. Alright, so let's try to draw a picture first. So we have x-axis here. And we have a y-axis here. It's terrible. So a y-axis here. All right. So here's the z-axis. All right. So what we want to do is we want to sketch first ellipsoid. All right. So first, I'm going to rewrite this in the standard form. So I'm going to just divide through by 64. Alright, then we have x squared over, let's see, 64 divided by 4 is 16. So 16 is 4 squared. And plus y squared over 4 squared. And 64 is 8 squared. So you have 8 squared. And it's equal to 1. Alright. So we have an ellipse, which is gonna, let's see, it's gonna, let's see, x direction, so it's gonna hit the 4 here. And of course, a negative 4 there. And a y is the same way, so you have, it's gonna probably hit somewhere here, so it's a 4 there, and a negative 4 there. Alright, then z is a positive 8 and negative 8. I have to kind of rescale it, so I'll just put the 8 here, so it's kind of a little bit squished there, but that's fine. So here's a negative 8 there. Alright, so I'm not really sure how to sketch it, so I'm gonna see. So it's going to be an ellipse, which looks, ellipsoid I should say, looks kind of like that, right? All right, then here, this is a terrible picture, but x squared plus y squared equals 9, so radius is 3, so this one I can do. So 3 is going to be here, and the 3 is here, and here is negative 3 and negative 3. So this is actually inside this ellipsoid. So the cylinder, I'm going to actually have to draw a cylinder. So here's the, so you have a circular cylinder. So I'm going to try to draw a circle like that. And then it's a cylinder, so it's going to go up like this. And you can see that it's going to pierce through the ellipsoid, and you have kind of a, it looks kind of like this. Right, and then it's gonna go down here, and then it's gonna, you can see this is going to be a hole. I think it's all inside, so maybe I should have drawn using a dashed line. All right, so what we want to do is we want to find the volume of that thing. Right, so first I'm gonna see, so we're talking about, let's try to find the just top half, then we're gonna double it because it's going to be symmetric. So this is what we're talking about. So you have a part of the cylinder here, and then you have a surface, so you have a hole there, so you have a surface. I don't know how I draw this. All right, so it looks kind of like that. All right, then let's set up integral here. So here's gonna the volume v, right? Then this is gonna be equal to, so it's a double integral, right, over this disk d. So I'm gonna call this guy d here, which is on the xy plane, right? So I'm gonna just do d, use d for now. Right, then top curve is defined by this ellipsoid, so I can solve this one for z. So it's going to be z squared is equal to square root of 64 minus 4 x squared minus 4y squared. Sorry, I already took the square root. So this is going to be the top one, so it's going to be a plus. And I think we can factor out the 4. So it's going to be square root of 4 is 2. So this is going to be simply 16 minus x squared minus y squared. Right? So we have that. So I'm going to put, let's see, there's going to be 2 square root of 16 minus x squared minus y squared. All right, but this is going to give you only a top half, so I'm going to multiply by 2. So I'm going to put 2 here. Right? Then we're going to do dA. Right? So that's what it is. Right, so the next step would be we want to rewrite it as in polar coordinates. Right, so 2 is still there, and it's a double integral. Right, and maybe I can probably combine 2 and 2 first. So instead of 2, I'm gonna put 4. Right, then this is going to be a square root of 16. Right, so you have x squared and then y squared, so that's going to be r squared. So I'm going to have minus r squared. All right, then you have area element is r dr d theta. All right, and the theta is going from, all right, so this is nice. This is just a circular cylinder, and the radius is 3. So r is going from 0 to 3. Then, in order to swipe out the whole disk, you have to, angle is going to go from 0 to 2 pi. Right? So we have that. Right, so let's evaluate this. I'm going to use a substitution. Let u be 16 minus r squared. Right? Then take the derivative of u with respect to r, which is going to give us negative 2r, right? Then I'm going to take the reciprocal of both sides. So you have dr over du is equal to 1 over negative 2r. Then I'm going to multiply through by du. dr is equal to du over negative 2r. Alright, then we can, let's see, we need to do the conversion. So originally, r is going from 0 to 3. So we want to convert it to a u value. Right, if you plug in u, 16 minus 0 is 16. 16 minus 3 squared would be 7. Right? So we can rewrite this integral as 4. Right, so you have an integral from 0 to 2 pi. Actually, this is a separable. I'm going to go ahead and separate it. So you have a d theta times. So we have an integral. Now this is going to go from 16 to 17. Right, then we decided to call this guy u. Right, so that's the substitution. And so it's the square root of u, so I'm going to write it as a u to the 1/2 power. All right, then you have a r. All right, dr is equivalent to du over negative 2r. All right, then we can simplify. Let's see, r on top and r on the bottom cancel out. And also, we can use this negative sign to switch the lower limit and upper limit. So it's going to go from 7 to 16. All right, so let's integrate it. So this is going to be, right, also, we can do this too. We have a 2 on the bottom here and cancel that. So it's going to be just 2. All right, so this is going to be 2 times antiderivative 1 with respect to theta is theta. And it goes to 0. From 0 to 2 pi times antiderivative of this is a u to the 3/2 power. Divide by 3/2 is equivalent to multiply by 2/3. And this guy is going from 17 to 16. Right? So this is going to be equal to, right? So you have a 2 times 2 pi minus 0, so this is just 2 pi, and times 2/3. Right, then you plug in 16, so 1/2 power of 4, 4 cubed is 64, minus 7 to the 3/2 power, so I'm going to write it as a 7 square root of 7. Right, so if you multiply them all together, you got 2 times 2 times 2 is 8, there's a pi, and the 3 on the bottom, then you have 64 minus 7 square root of 7. All right, so let's type it in. All right, we got the, let's see, it was 8 pi over 3 multiplied by 64 minus 7 square root of 7. All right, so let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.